In this session, we're going to evaluate polymerization. And to enable us understand this, we're going to say that polymerization is the synthesis of small organic molecules into long continuous chains. The conditions under which the synthesis occurs dictates the nature of polymerization that takes place. Namely, condensation polymerization occurs whenever there are saturated hydrocarbons involved. Addition polymerization, on the other hand, occurs whenever there are unsaturated hydrocarbons involved and where there is heat and pressure at play. Let's take a look and see how this occurs. Namely, in the first case, we have ethene combining with ethene. Now, if we assume that ethene is a monomer, which means a unit, and another ethene is another monomer, meaning a second unit, given that there would be pressure and heat present, the pressure present in the interaction between ethene and ethene will mean that the double bond will be compressed and broken. Now, the pressure that breaks the first double bond is the same and will break the second double bond in equal measure. The net result is that the two successive ethene molecules are going to interact more effectively with a free or delocalized bond in between them. And because of the presence of the heat will make the two bonds adhere to each other. In other words, the ethene in the first molecule will adhere to ethene, the second molecule, thermally. All this will happen, and we've realized that no molecules are discharged, in the sense that each ethene had a network of 4 hydrogens and they are retained in the process. Now, when the chain changes from 2 carbons into a long continuous chain of 4 carbons, we can say that there is a direct synthesis between ethene and ethene to form polyethene. So polyethene is a polymer, and this polymer comes from 2 monomers, namely ethene and ethene monomer. We can therefore say that this is a self-addition reaction which happens in the presence of heat and pressure, and which does not lead to the loss of any molecules, but simply leads to the adhering of the first molecule to the next one by the prevailing conditions. In a nutshell, this is a form of addition polymerization. In the second case, we have amino acid. Now, an amino acid is a saturated form of hydrocarbon formed of an amide and an organic acid. Now, when the amino acid meets a second amino acid, there will be a direct interaction between the hydroxyl unit and the hydrogen unit in the intermediate center of the two substances. The hydroxyl unit from the carboxylic end will combine with the hydrogen unit from the amide end to form water through the process of condensation. Now, during this condensation process, the remnant molecules will synthesize gradually. And as they synthesize gradually, they form a long continuous chain of hydrocarbon by the process of condensation polymerization. Now, let's see how this occurs. Now, as you can see, the bond which was broken was between hydrogen and hydroxide. The remnant species is now only a carbonyl and a nitrohydride, having lost one of the hydrogens. The next part is a continuation of the chain which previously has been there, the way it has been. However, we realize that the overall effect is that water has been lost as tiny molecules. And this loss is what signifies the process of condensation to have occurred. Therefore, we can comfortably describe this as a form of condensation polymerization. What then is the difference between condensation polymerization and addition polymerization? First and foremost, we have seen that amino acid combines with amino acid to form polyamino acid through the process of condensation. The amino acid is a monomer combining with the second monomer and forming the final polymer, which is polyamino acid. Now, this polymer is also referred to as protein. So protein is a polyamino acid. And protein is a natural substance. So, coming back to my question, what is the difference between the two forms of polymerization? Namely, addition polymerization and condensation polymerization. To begin with, we are going to look at what we are calling the addition polymerization. As you have seen in addition polymerization, we had ethene combining with ethene, and each of them was unsaturated. The presence of the unsaturated double bond provided room for breakage and synthesis. The conditions required were heat and pressure. Therefore, we can conclusively assert that addition polymerization involves the unsaturated hydrocarbons such as alkenes and alkynes. Number two, addition polymerization is enhanced by the presence of heat and pressure as the prevailing conditions. And number three, when addition polymerization occurs, no atoms are lost simply because the interacting monomers simply synthesize without the discharge of any atoms. Period. Now, what then is condensation polymerization? We can say that condensation polymerization involves the saturated hydrocarbons such as the peptides. We have seen the first form of peptide as amino acid combined with the second form of peptide, which is another amino acid, and forming a polypeptide, which is a polyamino acid, and in the process losing water as tiny molecules. The process of loss of water during this synthesis signifies condensation, and therefore what properties are carried here is that condensation polymerization involves saturated hydrocarbons. 2, it does not require any conditions, namely heat or pressure. And 3, whenever it occurs, there is a loss of tiny molecules such as molecules of water. In summary, therefore, we have said that there are two forms of polymerization, namely addition polymerization and condensation polymerization. Remember, polymerization is the synthesis of small organic molecules forming a long continuous chain, and the condition thereon dictate whether it is going to be a simple addition polymerization or a condensation polymerization. We have also seen that in addition polymerization, there are no loss of tiny molecules, and 2, that there is requirement of heat and pressure to effect the synthesis of one monomer to the other. And the overriding condition is that the reacting molecules for addition polymerization have to be unsaturated. In our conclusion, we have said that condensation polymerization is a process by which saturated hydrocarbons interact and lose tiny molecules through the process of condensation. The condition required is no heat, no pressure, and no any other prevailing circumstances. And therefore, we can say again that condensation polymerization occurs naturally and superficially without the loss of with the loss of tiny molecules through condensation, and ultimately that the overriding requirement is that the reacting species have to be saturated for them to undergo condensation, leading to the loss of tiny molecules such as water. Thank you very much. That has been a description of what we are calling polymerization and the two distinct forms, namely addition and condensation.